Okay. So hello, everyone. My name is Maciej, and I'll be talking about character encoding in MySQL, about how you break and then maybe fix your data that it was incorrectly encoded and stored. Okay, so let's start. So we view documents as lines of text, but computers have to see that data, see that information as binary data. And so characters become numeric values, numeric codes, and these codes become character encoding, where a letter becomes a number. There are two most popular encoding types, which is ASCII, obviously, and Unicode. Collection of certain characters encoded in a certain way becomes a character set, which could be for a language like Latin 1 or Latin US, which covers US English, or English in general. Latin 1, which covers most of European languages that do not really need all fancy characters. Latin 2. Also, you'll have characters that use Unicode encoding, which can be multi-byte encoding, where a character takes from 1 to 4 bytes. And these could be more complex character sets, like Asian languages or pretty much anything these days. So character set is the context that sort of defines what each character code means and what it becomes when it's printed on the screen on a printer or whatever. So when the context is lost, we no longer can tell what a specific code means. What is 65? Is it A? Is it a question mark? Is it an exclamation mark? We don't know that. So the character set defines that for us. If we mix up the character set, then we are most likely unable to figure it out anymore. So what can go wrong, or when can things go wrong? So this session is about breaking and fixing character encoding. So encoding is maintained on multiple levels, from the presentation layer, like a web page or a terminal or anything else, a screen, down to the data storage, so tables, columns, and so on. This offers this multi-level layer support offers flexibility in how this is how we can access information, how we can display information and store information. But it also creates complexity. This is flexibility, but it also creates complexity that often leads to problems. In the next few examples, I'll show you what these problems can be, how they occur, and later how to fix some of those. So problem number one is, and this is in MySQL specifically, is that MySQL by default is Latin 1. So its default character encoding is Latin 1. When you install it out of the box, this is what it will be using. And this also applies to the upcoming MySQL 5.7, I think. And well, most people these days don't bother really looking at that, because they generally will assume that, well, okay, it's a tool I need to use, so it will support it will be multilingual. It will support whatever I want to store or read from it, right? It's 2015. So people don't really look at that too often. So we kind of will start following this process of building applications. So we start with a clean MySQL and a new application. Both server and client use Latin 1 by default for no reason. So we create a schema. And we create a first table to support our application that will allow users to store the places where they live. So we have all these people coming in. And then, of course, when we create this table, the server uses the default encoding for this table. It says Latin 1. So we have a new table that will use Latin 1, of course. So we have this application where people come in and add their cities. And so we someone from Germany, someone from Poland, and then there is this guy from Japan who, what I believe should be, tries to enter Tokyo using his own letters. So he hits save, and voila, it's great. It works, right? Everything displays correctly. So the problem is that we created a table that is Latin 1, and Latin 1 doesn't really support Japanese characters. It's not in the Latin. It's not in the character set. These characters are outside of this character set. But it works, so we are probably fine, right? Well, actually, we're not fine. So what Mysql does when it sees a client and a data, it looks at the character set that they use. If the character sets are different on both ends, it will try to perform an on-the-fly conversion so that the client gets information in the character set it wants. So we set character set to UTF because, well, we expect input from all around the world in different languages. So we set this in UTF, and Mysql converts our cities into garbage. So it is definitely not right? Interestingly, if we set it to Latin 1, we got all the right things. So, well, the data is kind of correct, but in a kind of weird way. So, is it a problem? Well, I guess you can live with that. Well, application works, it's fine, so you can use it, and there appear to be no problems. But there may be such time where something goes wrong. So, for example, you'll try to upgrade Ruby, and an older Ruby will work with that, and the newer Ruby will tell you, okay, but this Japanese character doesn't really make sense in Latin 1, so I won't get this data for you. So this is where the place where you need to start thinking, okay, I need to fix this, right? So you start fixing it. So you update the server encoding, you set the client encoding right, you convert data, tables, and whatnot, and obviously you get a table that is now done correctly. It uses correct Unicode encoding. So the good news is it's sometimes fixable. You can fix the encoding without losing anything or breaking anything. So then we move to kind of problem number 2. So I said that encoding or character sets are handled on multiple levels. So in Mysql, you have 5 different settings alone to define what's going on with data, how it's translated, how it's encoded, and how it's converted. You'll also have schema level defaults, table level defaults, and of course column character sets, which define the actual storage character set, so how the data is stored in the tables. So we fixed our first problem, right? We converted data back into, we converted it into UTF, so it's now done correctly. And we continue to develop our application. So we add new functionality that is, will allow people to add their names, right? So we create a new table, and, well, we start our application. So there were 2 guys who already added their names, and I decided to mine as well, and I click save, and then, and then I have a question mark in the middle of my name. So we fixed the problem, but apparently something is still wrong. So we log in, we see that our settings are generally correct, but we look at the table, and it's Latin 1 for no reason. So why? Well, we started investigating configuration, and we see this character set database that is Latin 1. Why is it? Well, because when we first created the database, we had the server running with Latin 1 default encoding. So the database got its own schema level character set to Latin 1, and we've never fixed that. We converted data, we converted tables. That was fine, but all new tables that we kept creating later were receiving this old encoding associated with a schema. So can we fix this problem? Well, we started digging, and it turns out that my accented N in the last name became a question mark, and it permanently became a question mark. So at this point, there is no going back. I mean, we only have data that has a question mark. My name will always have a question mark in it. If you know my name, you can fix it, but you will not know all the answers for all the rows in all tables. So essentially, this means that this data is broken beyond repair for one silly reason. So it may not be enough to set up server correctly. You have to be way more careful with that. Also, it's even more dangerous if you get difference between the server and client encoding because of the implicit conversions that I mentioned before. So going back to all these different settings that you can do in MySQL. So the reason that it happened, the second problem happened, was that schema level defaults, they affect new tables. And table level defaults affect new columns. So what you see in the table definition as a default character set will only be affecting any new column that you add without specifying the character set. And what you see in the schema definition will apply to any new table that you create without the default character set specified explicitly. So we have some more examples of that. So we have this, we create a schema. We have a server that runs Latin 1, and our client uses UTF-8, right? So we create a schema, and the schema receives the server's default encoding, which is Latin 1, regardless of our client setting. So then we go into the schema, and we create a table. A table will obviously receive the schema's default encoding, which is also Latin 1. So then we change the default schema, default character set for this new table to UTF-8, right? And what it turns out is our column suddenly is still character set Latin 1. This is not displayed here because the column character set matches the table's default character set. But as soon as there is a difference, the column has this additional text stating that it's a default encoding that the table's default encoding. So this is what can happen. So changing table's character set to something else doesn't really fix the problem because column remains as Latin 1. It's kind of set independently. So then we can add a new column to this table, which is already UTF. So you can see the new column has no character set mentioned in this output, which means it is UTF-8. It is the same as the default encoding for this table. So essentially, when this happens, when you have all these problems with characters, when you have like UTF data stored in Latin 1 tables, what you can do? Well, first, it's important that you don't act too quickly. You have to analyze the situation, figure out what happened, why it happened, then reassess the damage. Figure out if the problems are consistent, if all data is broken in the same way, are some tables broken in a different way, or maybe they are broken in several different ways. So each case has to be handled differently, so you have to know that. You have to also figure out if the data is repairable. Sometimes it's not. So what you shouldn't be doing? Well, you shouldn't act too quickly because you can actually break things even more. You can't fix this on a replication slave because replication will, if you start converting data on a replication slave, replication will continue to send you bad data. Replication carries character set information and encoding. You can't really fix this one by one, tables one by one, because this change in the application or server has to be sort of atomic. So if you switch from Latin 1 to UTF-8, it affects all tables on all communication. So you can't really do that. It has to be in sort of one go. And you don't want to use these if you have a broken character set encoding anywhere, because these generally assume that everything is OK. They will convert data, or the last two at least, but only under assumption that everything is right. So what needs to be fixed? Schema, default character set, like I mentioned, all the text columns in the database, Also enum, which isn't really a text column, but it carries some text information. You can grab all these columns, all these tables from the information schema. Other tables that do not have text information in them, you should eventually fix as well. They won't be affected by the existing problems, but you may want to add new columns to those tables later. And if they are Latin 1 instead of UTF, you will get Latin 1 columns again. So what are the options? Well, you can do dump and restore. If you just tell Mysql dump to use the same encoding as the data, as the tables use, so you use Latin 1 to dump from the Latin 1 tables, this will keep the implicit conversion and will, for example, export the UTF data correctly. Then you recreate everything, edit the Mysql dump to update table definitions, and import everything as UTF into the server again. The other option is to use alter table and convert each column separately by converting them into binary form and then back into UTF. Converting the column data or table data into binary encoding means that basically you drop the character set context, so there is no conversion applied either way. So this way you can kind of, having UTF data in a Latin 1 table, you get it into a binary form without any changes, and then you get to UTF without any changes as well, so it's correct. And the last option that we developed recently is to use PT Online schema change to do this online without pretty much any downtime. So we wrote a plugin that we use with a PT Online schema change and a slight modification of the PT Online schema change to actually let it work. That works like PT Online schema change, so you can perform your conversion online. The only kind of requirement is that you don't rotate your tables as they are converted. So you end up with a database that is twice as large, with all the tables having both new and old versions. And then when everything is converted, you start your application, you fix your broken configs and everything. And then you rotate the tables. You basically replace the Latin 1 tables with UTF tables, for example. So the downtime could be less than a minute. There could be a few gotchas, which is if you convert from Latin 1 to UTF, your storage requirements may increase. So you may need to increase the column length or change the index length to accommodate the new requirements. Also, there could be more problems than you think. So this function can test if the conversion worked. So you can compare all pre-conversion value with a post-conversion value and test if it actually worked correctly in an automated way. So you can apply it on all data in the database. So how to do it right? Set the character set during initial configuration. Always explicitly specify default character set for everything, including tables, columns, and schemas. And of course, don't forget to set up your applications correctly as well. Okay, and one more thing which is not related to that. If you're interested in web scale SQL, we are sharing this with everyone. We've been using this and building binary packages for them for a while. So we are now sharing them, the web scale SQL packages with you, and you can grab them and test them. The amazing web scale SQL from Facebook, Twitter, LinkedIn, Google, and others. Okay. Any questions? Yep.
Do most of these same tricks apply to converting from UTF-8 to UTF-8 MB4?
Sorry?
UTF-8 MB4.
Yeah.
Should be a problem.
No, won't be a problem.
Cool.
That's all.